Now on to the most annoying of cases, which is when we can't think of stuff that we should supposedly have in our long-term memory, or in other words, colloquially, we call this forgetting. We can ask the question, however, if forgetting truly happens in long-term memory, or if there's some other processes that come into play, and that forgetting is not necessarily characterized very well by just stuff dropping out of your brain and out of your mind. So, how do we measure forgetting? Well, forgetting you can obviously measure by how much we manage to recall, and whatever we don't recall, we apparently have forgotten. Or we can look at how much people actually have retained. So retention is sort of the flip side of that. And then the way to to study it is by either again free recall or recognition, or sometimes people use the time it takes you to relearn, let's say, word list on the second day after you knew the first list on the first day. So imagine I give you a list of 40 Latin words, and on the first day it takes you, an hour to remember all of them. Then the next day, I can assure you that if I test you right away, you're not going to remember all 40 of them. But if you start studying them again, it's not going to take you the full 40 minutes to relearn, or an hour to relearn it. It's going to take you a shorter amount of time. So that time of relearning is some indication of how much was, even though it wasn't explicitly there, maybe implicitly it was encoded anyways. What do we know about forgetting? Well, forgetting is one of these situations where somebody got really, really interested in it and started to very systematically study it. And in this case, the person who did this was Herming Ebbinghaus. And Ebbinghaus was very, very fascinated by forgetting, to the point that he actually decided to study it in a systematic way. And what he would do is create long, long lists of complete nonsense syllables that he would write down on a piece of paper. And then he would study these lists over and over and over again, until on day one he would be able to recall all of the lists on all of the words on, or the nonsense words on that list. He would then come back and day two do the exact same thing, test himself on how much he had forgotten, and then also test himself on how long it would take to relearn the information. Well, what did he find? When he plotted what's called the saving score, meaning how long did it take you the first time to learn the whole word list minus how long did it take you to relearn, he actually found that when he knew the full list and was tested right away, in that case it was 100% score. But if he only waited 19 minutes, the score went from 100% down to 60%. If he waited an hour, it was down to 45%. If he waited 10 hours, almost, it went down to about 35%. And then what's interesting is that after the days after that, it actually flattened out a lot. So in other words, what you can see from this curve are a couple of things. First of all, about 50% of the information was forgotten, quote unquote, right after people learned it. So you study this list, you have everything in there. 40 minutes later, half of that list is gone. Unless, of course, you go and repeat it again and keep studying it. That's the first point. Second point, though, is that you can also see from this curve that about 25% of information actually made it in and stuck there, because even 31 days later, that information was still there. So clearly in this graph, the relationship between how quickly you're forgetting and how much time it takes is not linear. Originally, in the first hour or two, you forget a lot of it, more than 50%, but then it flattens out in this asymptotic way, where basically then at 25% or so, that's actually the information that will stay in your system. So what about retention? What about the amount of information that we remember after some time interval has elapsed? And how does it depend on how many times you studied the information on a particular day? Well, turns out that the answer to that question depends on how you're being tested. What I mean by that is this. You see in both cases here, again, the same sort of forgetting curves that I just showed you for Ebbinghaus, except in this case they had two different versions. They had people studying information and then they were tested either by free recall, which is this red curve, and you see after different amounts of time elapsed, or they were tested with multiple choice where they just had to recognize the information. Interestingly enough, you see that the rate of forgetting, of information dropping, is much steeper for active recall than it is for recognition memory. And that's interesting because if you were to take a test in this course, for example, that would consist of some open questions and some multiple choice questions, you would actually be well advised to start with the open questions because those open questions fall on this memory curve. So, in other words, the longer you sit in that testing room, the more that information is fading. And after an hour, you're at about 50%. If you had answered these open questions right away, your chances would have been a lot better. Recognition, the drop-off rate is not nearly as steep. So even 4 hours later, you would still be at 90%. Even a day later or even 2 days later, you would still be at about 75%. So, in other words, and you guys all know this, the way in which you're remembering things and how well you can perform on tests is going to massively depend on the way in which you're being tested. Now, based on what Ebbinghaus discovered and this drop-off, can we actually conclude that we forget, and if so, why is that the case? Well, turns out that there might be a couple of things we can say about this. First of all, it might be that some of the information that we think we're forgetting, we actually never fully encoded. And let me give you an example of that. If I show you a bunch of pennies from the United States that you've certainly seen a whole lot of times, and I ask you which one of those is actually the correct organization of a US penny, I bet you that most of you don't find this an easy question, even though it should be. I've seen the penny many, many times. And it's so bad, actually, that as I am sitting here, I've in fact forgotten which one is the correct answer, and I would actually have to go find a penny in order to be able to say which one it is. So I invite you to do that. I believe it's J, but I might in fact be incorrect. Point behind this is that even though this may look like I've forgotten what a penny looked like, it may just be that I never even encoded it at that level of detail. Because in reality, right, do I need to really know exactly what the organization of the different parts of that penny are in order to recognize that it's a 1 cent coin that I can do something with? No, not really, right? So as long as I can recognize this as money of some certain value that I can use for something, there's no need for me to exactly remember the details of what that penny looks like. So in that case, I just haven't encoded the information fully. Decay is another possibility that people, of course, bring up. Well, maybe it's just that if you don't use the information, you just lose it. The memory traces that we have in our brain may just erode over time. And for a long time, that was a pretty influential theory. But at this point, this is not really considered a valid theory of forgetting at all anymore, at least not in long-term memory. Why is that? Well, first of all, there's no good physiological evidence that this actually happens in neuronal connections. So that's first of all. And you can actually see this if you think about cases of language learning where maybe a child grew up in one country and then maybe at 10 years of age or 5 years of age moved to a different country and did not hear the original language, their native language anymore. If they are then tested 50 years later, they may not be able to actively produce that language, but they can certainly still recognize the words that they had been taught and that they used to know. So in other words, even though they don't have a high state of activation and come rolling right off of their tongue, the memory itself is definitely not decayed to the point that those traces are no longer there. So what is it instead then, if it's not decay? Well, it turns out that it's mostly about interference. And I'll say a bunch about that, and interference is related to inhibition of material or some obliteration of material by old material by new material. So what happens in interference theory? Well, basically, the idea is this. Sometimes we seem to have forgotten stuff because we have either old memories that interfere with new memories, or because we have new memories that interfere with old memories. When old memories interfere with the ability to remember new things, this is called proactive interference because it's forward working. Pro, right? Forward and then active. So that's proactive interference. Old memories are making it harder for you to remember new things. Sometimes we also suffer from retroactive interference, where new memories are actually interfering with the ability to remember old stuff. And interestingly about interference, the more similar the material is, the stronger the interference can possibly be. So let me give you an example of how this could work. Imagine that you are this semester taking two different courses. You're taking a course in economy, in economics, and you're taking a course in psychology. Let's say that later in the day you have an economics test, and you get up in the morning and decide to study for economics first, got it down, then have some time left and you think, well, let me study for psych for a little bit as well, and then you take your economics test. Retroactive interference implies that what you're studying in psychology after you studied economics is actually negatively impacting your memory for the material for economics. And that is called retroactive interference. So there's new information being learned here, and it's actually hampering your ability to recall the old information learned there. So that's retroactive interference. You can also have the exact opposite. It's called proactive interference. In that case, same scenario, except now, rather than studying economics first and then psychology, we decide to study psychology first and then go on to study economics, and then we have the economics test. In that case, it's also possible that the fact that you started with studying psychology is actually proactively interfering, forward working, it's interfering with your ability to study economics, and as a result of that, you do more poorly on the economics test. You see that both of those processes in principle can always be at play at the same time, right? That is entirely possible. The other thing about this is, if you think this true, right, there are actually two ideal times of day for you to study. The first one is first thing in the morning, because in that case you don't have proactive interference happening. There's no active information from before because you were sleeping, and the first topic that you study is not subject to proactive interference. The second time of day is right at night, right before you go to bed, because there you don't have later information that's going to work backwards to negatively impact your studying. So in that case, you're knocking out retroactive interference. And both of those can, of course, be useful.